have to prove root 7 as an irrational number. For that, our step 1 is let root 7 is a rational number. Okay, Nama? So step 1, let root 7 is a rational number, ma. That is, root 7 is expressed as some p by q where p comma q are co-primes. Okay, Nama? Now step 2, ma. Coming to this step 2, we have to squaring on both sides, ma. That is, root 7 whole square is equal to p by q whole square, ma. That implies 7 is equal to p square by q square. Just transfer this q square to this left side and transfer back this 7 to the denominator, ma. Then q square is equal to p square by 7. Here see, this p square is a square number and 7 is a prime. That means the square number is divisible by a prime 7. So that number is also divisible by the prime 7, ma. That is theorem 1.6. Okay, now that is clearly p square is divisible by prime 7. Okay, now so p is also divisible by 7. Okay, Nama? So we have to express that p as some 7 into x, ma. That is our equation 2. Why? Because this p is divisible by 7, ma. If a number is divisible by some prime p, that number is expressed as that prime into some other number, ma. That is why p is expressed as 7 into x. Okay. Now I will substitute this p value in equation 1, ma. Okay. Substitute 2 in 1. By that we will get q square is equal to 7x whole square by 7, ma. That gives us 7x square. Why? Because 1 7 and another 7 is going to be cancelled here. Okay, now I will write from this x square is equal to q square by 7. This 7 is going to be transferred to the left side. Okay, now just observe this one, ma. Again, this step 2 is going to be repeated here. So x square is equal to q square by 7 means, okay, now sorry, ma, this is step 3. This is step 4, ma. Okay, and this step 3 again going to be repeated here. Why? Because see, that q square is divisible by the prime 7. So that q is also divisible by the same prime 7, ma. So I will write that is q square is divisible by prime 7. So q is also divisible by 7, ma. Okay, na? That is q is equal to some 7 into y. Okay, na, ma? So we have to assume this as 3. Okay, na? 1 c, ma. From 2 and 3, p comma q are having 7 as common factor. Okay, but p comma q are co-primes, ma. As p comma q are co-primes, p comma q must have 1 as the greatest common factor. But here we arrived that 7 as the greatest common factor. That contradicts our assumption. That means that opposes our assumption. So our assumption is wrong. What is our assumption, ma? Root 7 as a rational number. That's our assumption. So this assumption is wrong. That means root 7 is irrational. Okay, now root 7 as 7 as common factor. So it contradicts our assumption that is step 5 ma, that is root 7 is irrational. Root 7 is irrational. Okay, I hope you understand. Now if he asks you to prove root 13 as an irrational number, just replace that 7 with 13 ma. Okay, I hope you understand.